This is the hardware schematic for polarization encoded BBM92. This is a network link that we've actually built in Boston at our headquarters, whereby we have this entangled photon pair source in the middle. It's generating and spitting out pairs of entangled photons with that HV plus VH state. Now we send one photon to Alice and the other photon to Bob over some fiber. Now, Alice and Bob have essentially the same set of hardware for measuring the quantum state. Okay, so let's kind of walk through sort of the day in the life of a photon pair. So our source generates these pairs of photons at very high rates. And one half of the pair arrives at Alice, and it hits this beam splitter. Now, this beam splitter is a component that, as the name suggests, will split the beam of light that you're getting from the source. So the beam splitter, essentially half of the time it will reflect off of that mirror and go towards the downward path, and the other half of the time it will pass through that beam splitter and go to the left. So this is a beam splitter is a passive component. You can think of it essentially as a prism that does this random basis selection for us, right? So if it does reflect and goes to the bottom arm, we consider that one basis measurement apparatus. And if it does pass through, it goes to a different basis. In another way, we measure the quantum state. So this is really nice because we don't need any sort of active, randomly selected basis system, right? I mean, in principle, one can use some kind of random number generator to decide, okay, at this point in time, which basis am I measuring in? That gets more complicated. So with a beam splitter, it's a really nice passive component that does this for us, and it does this random selection. Now, once the basis is selected, we actually have to project that photon onto a certain polarization. So we use a polarizing beam splitter here, similar kind of functionality as the beam splitter, but it does have that polarization filter on it. So essentially, half the time we are projecting onto the V basis, the vertical polarization, and the other half to the horizontal polarization. So this is essentially projecting the photon we get onto a certain state of polarization. So if it does hit the H detector, we know the photon was horizontally polarized. If it hits the V detector here, that's highlighted, then we consider the photon was measured in the V state, in the vertical polarization. And we do the same for the other basis, right? Diagonal and anti-diagonal, A and D. So those are what the components do at the physical layer.